So now let us start by first looking at what is the equation of a circle or how it is written. So let us assume this is our circle and this is a fixed point which has been given to us, which is the center, and it can be written as h comma k. And let's say the radius is r. The radius of the circle is r. Then its equation is written as x minus h whole square, x minus h whole square plus y minus k whole square is equals to r square. Now this is the standard form in which an equation of a circle is written. Now whatever be the h and k, we are to substitute it in this place, and whatever be the radius, again it's going to be a constant term, so we replace it here, and that's how we get the equation of our circle. Now once we open this up, we are going to get again a general equation which is in the form of a second degree equation. So this is how the equation of a circle is given. So again, if we look at here, the standard form of circle when the center is at origin. Of course, when the center is at origin, that means the center is 0, 0. That means instead of h and k, we've taken h to be 0 and we've taken k to be also 0. Then we get this equation. Again, it can, once we remove the 0, we will get this equation, x square plus y square is equals to r square. Important equation you need to remember. R is our radius of the circle, so that is how it is represented. Again, here the same thing has been mentioned. Whenever there is a center with certain points mentioned in the graphical scale xy axis, h comma k, that time we represent the equation of the circle in this format. Now let us look at other ways of how we can represent the same equation of the circle. I hope you all remember the equation, the general standard second degree equation that we had studied in straight line, and it used to be ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0. I hope you all remember this. Now to transform this into a circle, this can be transformed into a circle only when certain conditions are applied. For this to be a circle, conditions are a should be equal to b and h should be equal to 0. Again, important conditions you need to remember. Same thing has been mentioned here. Equal coefficients of x square and y square. That means the coefficient of x square is a and the coefficient of y square is b. So a should be equal to b and the coefficient of xy term should be 0. That means h 2h should be equal to 0, which means h is ultimately equal to 0. So once we do this, what are we going to get? Our equation would transform into this format: ax square plus ay square plus 2gx plus 2fy plus c is equals to 0. Now from here, if I take a common, so this would become x square plus y square plus 2g by ax plus 2f by ay plus c by a is equals to 0. So this is generally how the equation of a circle is represented. Of course, we need to make the coefficients of x square and y square equal to 1. Then we would be able to plot that circle into the graphical scale. Now let us look further as to how this type of circles, for this type of circles, we can find out the center and the radius. Now let's say this is our circle given. Again, as we had seen here, 2g by a, we've considered a to be equal to 1 in this equation. Let's say a is equal to 1. That means b would also be same value and h is equal to 0. So this transforms this into a circle's equation. Now this is the circle equation that we've gotten. Now let us try to transform this into the standard form that we just studied. So let us assume that first let us take all the x terms together plus y square and the y terms together, and let us put the constant term on the other side of the equals to. Now let us try to convert this into complete squares. I hope you all remember here we had seen that in the equation of a circle there were two standard squares, perfect squares here. So let us try to transform this into that as well. What if I add g square here? So this would become x plus g whole square. And similarly here we would have to add plus g square. And for this one, what if I add plus f square? And of course, to balance it out, I have to add f square on the other side as well. So ultimately this would transform as 2x square plus 2gx plus g square plus y square plus 2fy plus f square is equals to, I'm keeping the all the constant terms on the one on the other side, which is plus g square plus f square. Now this can be transformed into a perfect square, which becomes x plus g whole square plus y plus f whole square, and this is equal to, let's say, root under g square plus f square minus c whole square. I can write this in this format. So now you can see that this has been transformed into our standard format, which was x minus h whole square plus y minus k whole square is equals to r square. So from here we can say that our radius is equal to root under g square plus f square minus c. That is exactly what has been mentioned here. And our centers would become, again, this can be written as x plus minus g, sorry, x minus g whole square. So this minus g becomes our h. So that is how we find out the center. So now again, you can obviously find out the center and radius after converting this type of equations into the standard format and then find out the radius and center. However, it becomes very lengthy and difficult for you, so it is better to remember these 2 points, where for this type of equation of circle where x square plus y square plus 2gx plus 2fy plus c is equals to 0 has been given, the center is simply written as minus g comma minus f, and r is written, radius is written as root under g square plus f square minus c. So this is basically the breakdown of the circle's general equation. X square plus y square, again these are the quadratic terms that represent the circle. 2gx plus 2fy, linear terms that translate the center of the circle from the origin, and c is a constant that adjusts the size or the radius of the circle basically. Again, this is not a very important thing that you need to remember. Only thing you can remember is the center and the radius, most important things. Now there's another way of how you can write down the equation of a circle. Let's say a circle has been provided, the center has not been given to you, neither the radius. However, the diameter has been provided to you, and the diameter is at 2 points, let's say x1 comma y1, and this is q point, which is x2 comma y2, and they say that this is our diameter. Of course, we can see that this is our diameter because it passes through the center of the circle. If this has been provided, then directly we can write down this equation of our circle in this format: x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equals to 0. So directly you can represent the equation of circle in this format. Again, an important thing you can remember, otherwise it would become very difficult for you while solving questions. You would have to find out first the center. Using the midpoint formula, you can find out the center for this. Then you will have to find out the distance between the center and one of the diameter points so that you can find out the radius, or you can find out the distance between these 2 points to find out the diameter. Then diameter would be written as 2r, and then you would write the standard equation. Again, it becomes a very lengthy process, so directly you can write down the equation of the circle using this formula. So this was again another format of writing the equation of circle in diameter form. Now let us study about the parametric form. I hope you all remember when we had studied straight lines, we had studied a parametric form. Let's say if one of the points in the circle is known, x1 comma y1, and we had to find out any point p which is x comma y. Let's say the angle was also given, then we knew how we could find out x and y. Similarly for the circle, let's say the center has been given to you, h comma k, the radius has been given to you, r. Now we have to find out any point which is p, x comma y, in terms of r and h, r, h and k. So this is how they are written. X is written as h plus r cos theta, and y is written as k plus r sin theta. I hope you all remember I had told you that these parametric equations are usually used to find out the locus that are generally given in the questions. Again, an important thing you must remember. And let's say if a standard circle has been given to you where the center is 0 comma 0, so what would the parametric form become? Simply r cos theta, and y would become r sin theta. Again, an important thing you need to remember, parametric form. We will look into a few questions so that your concepts become very much clear. So before that, first let us look at a few special cases of circles. Like suppose if in question they have provided you with certain information about the circle, then how can you write down the equation or form few known points about the circle? Let's say they tell you that the circle touches the x-axis. In the question they have given you somewhere that the circle touches the x-axis. So what can you make out from this information? That means this is our graph and the circle is touching the x-axis in this format. That means it just touches here. Now let's say this distance is a from the origin. Of course this is our origin 0, 0. Somewhere here our center lies h, k, and this is our radius r. So from here what can you say? That this point is a, 0. That means our h, of course it lies perpendicularly above this point, this foot point. That means h would be equal to a. And k, what would k become? This length is of course k. I hope you are understanding. Of course this is, since this is the y coordinate, that means this distance is our k. So this point becomes 0, k. So what would our radius also become? Since from here to this point on circumference we are taking out k, that means our radius also becomes k. So for this circle, our center is written as a, r, and where r is our radius. I hope you are getting it. Now, so this was one of the ways of understanding these question. Again, there is no new concepts here. Of course, this is just plain simple logic that we are using. Now, let's say if they had given you this information that the circle touches the y-axis. So what can you make out from this information? That the circle touches the y-axis. That means, of course, this point would be 0, k. Let's say if this length is k. So somewhere here, let's say if the center is lying, which is h, k. So what can I say? That means this distance would become h. As I can see that the x is, this point would become h, 0. So from here, what can I say? That my radius is equal to h and my center point can be written as h, k. So this would be r, k. So basically this is how the center and radius of these points are written. Again, this was just a special case just for you to visualize how a circle would look if it touches the y-axis or x-axis. Now let us look at a few more. Let's say if they say that the circle touches the x-axis at the origin. So what can we make out from this? That the circle is touching the x-axis at the origin. That means this is our circle. This point here is 0, 0. That means our center would lie somewhere on the y-axis. So for this one, we know that our x coordinate would be 0 and y would be, let's say, somewhat k if this height is k, and our radius would also be equal to k. So this is how this type of circle is represented. Now let's say if they give it in the vertical format, if the circle touches the y-axis at origin. So how would we draw the circle? This would be our circle and our center would lie somewhere on the x-axis. So we can say that if this distance is h, so this would become h, 0 and our radius would be equal to h. So this is how different types of circles are again represented. Let's look at a few more. Let's say what if they say that the circle touches both the axes. If the circle touches both the axes, that means the circle would be, let me first draw the circle. If the circle touches both the axes, that means it would be somewhat in this format. It is touching the x-axis as well as the y-axis. So from here we can find out what our h, k would be. Again, this distance here, this is our x, so this would become h. This distance here, this is our k. So of course, since h and k both are radius, here we can see that from the diagram. From the center, this distance is also h, and from the center, this distance is also h. And for a circle, of course, all the points on the circumference are at equal distance. That means h is equal to k and this is equal to r. So center can be written as r comma r, where r is the radius, k is equal to r, h is also equal to r. So this is how generally points are represented. Let's look at another format. Let's say if they say that the circle intercepts both the axes. Circle intercepts both the axes. That means our circle is in, that means our circle is in this format. I'm sorry, I'm not being able to draw a complete proper circle, but let us assume this is our circle. So this is our y-intercept that it has just cut, and this is our x-intercept that it has just cut. So this is one of the way of looking at it. Now let's say if they say that the circle intercepts both the axes and the circle passes through the origin as well, and passes through origin. So what can we make out about this circle? That the circle would be somewhat like this. So our circle would be somewhat like this. Somewhere here our h comma k would be lying. Now we know that this point is 0 comma 0, and we had studied this in straight line, that if there is any point that lies on the coordinate or on the geometry that we are dealing with, that point would satisfy the equation of that shape. That means the equation of circle is written as x minus h whole square plus y minus k whole square is equals to r square. 0 comma 0, that means the circle is passing through 0 comma 0, that means 0 comma 0 would be satisfying this equation. So from here what do we get? We can put x to be 0 and y to be 0 as well. This would be satisfying the equation. So from here we get one equation, that is h square plus k square is equals to r square. So this is one of the equations that we can find out from this information. Or if let's say I was to take up the general form of my circle, plus 2gx plus 2fy plus c is equals to 0. So if I put x and y 0 here for the origin, if I put x and y 0 here, so what would I get? C would be equal to 0. That means there is no constant term in this type of circle. That means the equation is written as plus y square plus 2gx plus 2fy is equals to 0. There would be no constant term for this type of circle that passes through the origin. Let's say if they had provided you that the circle passes through, let's say 2 comma 3, then you can of course satisfy this point in the equation of the circle to form any other equation of unknown variables that have been provided to you. So this is how special cases of circles are used, and these are general information that you must remember. All these geometries and ways of drawing the circle, you must remember this, because it will be helpful and easier for you to solve questions during JEE mains. Now we will look into some examples to clear our concepts a bit more.